Okay, so now we're gonna talk again, how do we predict using this line, okay? So, again, what we said is that the population of all houses where people who make 50,000 aren't going to have all the same size house, okay? They're not going to, so the predictor is basically, we're going to find out in a minute, is going to be more of an average. And I don't care if you know that quite as much, but that's basically what's going on. So again, the actual value, as you can see in this graph, for 50. Now remember what 50 means. 50 means $50,000, and it's very important when you predict that you use the units that they were doing, okay? That you don't plug in a 50,000, we're going to plug in a 50, okay? So if someone again comes to our community and says, hey, I make $50,000, how big a house should I expect to get? We're going to use this line. Now, of course, the home that they actually end up getting will probably be either a little bit lower or a little bit higher. This is just an estimate, okay? It's an estimate. So what am I going to do? I'm going to take that line I had, y hat, which was, remember, equal to 4.975. You can see here's the line, the equation of the line, plus 0.3539. And what I'm going to do is I'm going to plug in 50 for x. So I'm going to plug in a 50. You plug in the unit. So remember, 50,000. Don't plug in 50,000. You plug in a 50. And when you plug this into your value, into your equation, you're going to get out the y value, or the square footage of the home. And what you get when you do this in your calculator is 22.67. Now remember, this is in hundreds of square feet. So I'm going to multiply by 100. So another way of saying that is 2,267 square feet basically on average. But this is what we can predict for their home size. So when I say predict, that just means plug in the value of x and you get out the value of y. Okay? Now notice that this line, there's a positive correlation, and our line has a positive slope. So you can see that for people who make less money over here, their average home size is smaller than for people who make 50,000, and people who make more than 50, their home size, average home size, is even larger. So in this case, depending on what the income is, the average home size will be a little different, okay? So again, the predicted value is an estimate of the actual home size for this family, okay? The true home size is either going to be a little bit lower, like it was for this family, or a little bit higher. It's just an estimate. Now, when you predict, you need to be very, very careful, okay? So I have a warning for you here. We have to be very careful that when we predict, that we predict within the relevant range of the independent variable. What does that mean? That means, I'm going to turn back now to the first page and show you that, let's look at what the lowest value was for the family income. So let's see, the lowest value that we saw here was a 32. You see the lowest value? And the highest income that we saw was 70. So this is what we call the relevant range. You want to make sure to look at the independent variable and not predict outside of this range. So in other words, what that means is we don't want to predict for a family that makes, say, $200,000 or $100,000, because they don't live in this community, one. And second of all, they have other needs. So they may need a pool, and they may need more square footage or things because they can afford it. So you really want to stay, for your estimate to be a good estimate, you want to stay within that relative range of the X values, which again, here I showed you where that came from. So the X values in the original data range from 32 to 70. So we don't want to extrapolate. That's the word that we use. We don't want to go beyond those values. So again, you would not want to predict for someone who makes $25,000, because they probably wouldn't live in this community and these things would not hold, or someone who makes much more. So it would not be appropriate to use the regression line to predict square footage for an income of, say, 100 or 100,000, because they're completely different criteria. So again, when we predict using a regression line, you want to stay within that relative range of the X values. And I did put some exercises for homework for you to do where I kind of trick you into making sure that you remember this. This is very, very important. Okay? So this is where we are going to stop in terms of regression because we really don't have the time to go beyond this, but we would have gone into a little bit more during a normal semester. So work on the homework problems, and we'll talk more about this when we meet.